We're now on to the final lesson of the graphing and transformations chapter. And for the final lesson, we're going to be looking at how to graph absolute value functions and reciprocal functions. So let's get started. Reciprocal functions. You may recall from grade 11 math that a reciprocal function is when you have like a fraction. Usually your numerator will be 1 and your denominator will be some kind of function, some mathematical relationship. Like it could be a linear function, it could be a quadratic function, but generally when you have 1 divided by a function, that is a reciprocal function. Alright, so for a reciprocal function, basically when we're trying to graph a reciprocal function, we need to take all the y coordinates and take the reciprocal value of and we got to take its reciprocal values. So if I had the value of 2, the reciprocal of 2 would be 1/2. If I have a value of 3, the reciprocal of 3 would be 1/3. Let's take a look at the graph of y equals to x minus 2, and let's take a look at its reciprocal, which is 1 divided by x minus 2. So y equals to x minus 2, this is basically a linear function, and let's just create a table of values here. And once I create a table of values, these are my corresponding y values. So this isn't anything new. We've done this several times already. And now let's take a look at the reciprocal function. You'll notice that the x values have not changed, but let's look at the corresponding y values. Now there's two ways to get the corresponding y values. The first thing you could do is you could take the x values here and just kind of plug them into your equation, and you'll get the corresponding y values. So for example, if I put this 1 into this x here, I would get 1 divided by 1 minus 2, which would give me a value of minus 1. Another way you could have gotten this minus 1 value is you have the values from your original function, and just as the notes state, the reciprocal function takes the reciprocal of all the y coordinates of a function. So basically you would take all these y values and you would just take the reciprocal of the y values. So if my y value here is -1, the reciprocal of -1 is 1 divided by minus 1, which is minus 1. Now for 2 is undefined, and basically if you put this 2 back into your original function, you get 1 divided by 2 minus 2, which is the same thing as 1 divided by 0, and 1 divided by 0 is undefined. Also, if your original function has a value of 0, the reciprocal of 0 would be undefined. All you really have to do is, you just go to your calculator here, and if you do 1 divided by 0, you'll know that you'll get this error, meaning that it's impossible. So that's why we have this undefined here. All right, now what about the value? What happens when x equals to 3 now? Well, the reciprocal of, the y value of the original function is 1. So the reciprocal of 1 is going to be 1. And from the original function I have a 2 here, the reciprocal of 2 would be 1/2. And if my y value here is 3, then the reciprocal of 3 would be 1/3, which is 0.3333 repeating. Alright, so now let's move on to, and once again, if you didn't want to take the reciprocal of these y values, you could have just taken the 5 over here, plugged it back into your original equation here, so you would have 1 divided by 5 minus 2, which is the same thing as 1 divided by 3. Now, when you're graphing a reciprocal function, there are 3 main steps. Step number 1 is whenever you have a y value of 1 or -1, the y coordinates won't change, because the reciprocal of 1 is going to be 1. The reciprocal of -1 will be -1. So when you're graphing reciprocal functions, always look for the 1 and -1 values, because the reciprocal of these two values will be the same. And we'll practice this in the examples. Now the reciprocal of 0 is undefined, so make sure when you're graphing reciprocal functions that if you find points with a y-coordinate of 0, those will become a vertical asymptote. So take the reciprocal of all y-coordinates to find where the points of the new function is. And just before we get onto some practice examples, let me just go back to this original function here. Y equals to 1 divided by x minus 2. Let's just graph this just to give us a reminder of what a reciprocal function looks like. 1 divided by bracket x minus 2. And let's graph that. And this is what we get right here. So this right here, we have a vertical asymptote right here, this line, and that's at the point x equals to 2. So when you have an undefined situation, that just means you have this vertical line, meaning that the graph actually does not exist at that point. All right, so let's get into graphing reciprocal functions now. Given the following graph, draw the reciprocal function. All right, so here's my original graph. This is just basically a linear line, and I want to graph its reciprocal. All right, so step number 1 is when we're graphing reciprocal functions, we want to find the x-intercept. So on this graph, we want to find the x-intercept, which is right here. At that point, the y-coordinate is 0. And remember, if you take the reciprocal of 0, 1 divided by 0, that means you have an undefined situation. So at this point right here, x equals 2, you have a vertical line, meaning that you have a vertical asymptote because the reciprocal does not exist at this point. Okay, so that's step number 1. Just find the x-intercept of the original function because the x-intercept will become a vertical asymptote for the reciprocal function. The next step is you want to find common points with a y-coordinate of 1 or minus 1. So the key thing is we're looking for a y value of 1 or negative 1. And on this linear graph, I have exactly one point where I have a value of 1. So this 1 right here is actually right there. And this negative 1 is located right there. So that has a height of negative 1. So I'm just going to plot those points, 1 and negative 1. Because the reciprocal of 1 and negative 1 will be, 1 and negative 1. Step number 3 is pick some points on the original function. So the original function is this red line, and take the reciprocal of the y-coordinate. Okay, so we got to find a point on this line, and whatever point that we find, the corresponding y value, we need to take the reciprocal of that y value. And remember, the reciprocal of a large number will become small, and the reciprocal of a small number will become large. Okay, so let's take a look here. So consider this point right here. So I just randomly picked this point right here. It's really hard to determine the exact y height. So maybe this is about 0.2. I'm just taking an educated guess. It's hard to read the y value, but maybe it has a height of 0.2. And remember, 0.2, for example, is a small number. So when you take the reciprocal of 0.2, you should get a little bit of a bigger number. So the reciprocal of 0.2 would be 1 divided by 0.2, and that would give you a value of approximately 5. So if this is my value of 0.2, then the reciprocal would be over here. So 1, 2, 3, 4, 5. And how did I get 5? I had my y value here, which is 0.2. 1 divided by 0.2 would give me 5. All right, let's take a look at another point. Now this point right here, this point right here has approximately a y value of a half. So a half is once again a small number. So the reciprocal of a small number, we should get a bigger number. So if this point is a half, then the reciprocal of a half would be approximately 2. So there it is. 1 divided by a half is 2. And the reciprocal of 1 is 1. And now finally I have another point here. This has a y value of 2. 2 is actually a large number, so the reciprocal of a large number will become small. So the reciprocal of 2 is 1 divided by 2, which is going to be a half. And there it is. So there's 1 point, there's another point, there's another point, and there's another point, and basically we just connect the dots. And we get something like that. All right, so we're halfway there now. So now that we got this side of the graph completed, now we need to work on this side of the graph. So we got to find a few more random points. All right, so I have a height here. This looks like to be a small number. So the reciprocal of a small number will become large. So maybe this has a height of this has a height of -1/2, and the reciprocal of -1/2 would be -2. And here I have another very small height. The y value here is very hard to read, so I'm just going to take an educated guess, maybe -0.25. And -0.25 is once again a small number, so the reciprocal of a small number will become large. So the reciprocal of 0.25 is approximately going to be 1, 2, 3, 4, so about -4. So if I take the reciprocal of this, which is -0.25, like 1 divided by -0.25, I would get a height of approximately -4. All right, and then I have a height over here of -2. The reciprocal of -2 would be -1/2. If I have a height over here of -3, the reciprocal of -3 would be -1/3, which is about there. And if I have a height of -4 over here, the reciprocal of -4 would be about -1/4, about right there. So once again, here are all my dots, and I just connect them. There we go. And there we go. This blue graph right here and this blue graph right there, that represents the reciprocal function of this linear red line. All right, let's take a look at another example. Practice, given the following function, graph the reciprocal. All right, so for this graph right here, I have a parabola. And we want to follow the same steps from the previous problem. And the first step is find the x-intercept. Whenever you find the x-intercept for the original function, its reciprocal will have a vertical asymptote at the x-intercept. So my x-intercept is about here and there. That's when the graph has a y value of 0. So in this case, I'll have 2 vertical asymptotes. All right, great. Step number 2 is find the common points with a y-coordinate of 1 or -1. So for this graph, I need to find the points where I have a y value of 1 or -1. So here's a value of 1. There's a value of 1. Here's a value of -1, and here's a value of -1. All right, so those are my values where I have a height of 1 or -1, and finding the reciprocal of 1 or -1 would basically be itself. All right, next thing we have to do is we got to pick some points on the original function and take the reciprocal of the y-coordinate. All right, so now we got to find some random points. And once again, the reciprocal of a large number will be small, and the reciprocal of a small number will become large. All right, so going back to this third step right here, I need to find some random points. So here's a random point right there. Now I'm going to be very honest with you. I don't know the exact height. It could be 1/2. It could be 0.3. I'm really not sure what this height is, but I do know that this height right here is a small number. So the reciprocal of a small number will become large. So once I take the reciprocal of this, it might be up here, for example. Now here's another random point. This has a height of 1, 2, 3, 4. So this has a height of 4, which is a large number. So the reciprocal of a large number will now become small. So here I am. So my reciprocal should be somewhere down here. And there it is. All right, so I have 3 points, 1, 2, and 3. And if you want, you can just connect those dots, and this would be my reciprocal for that part of the graph. Now, over on this side, the graph will behave very similarly to this graph right here. So here's my value of 1. And once again, let's just find some random points. So here's a random point there. I don't know what the exact y value is. This height right here, I'm not sure, but I do know this height is a small number. So the reciprocal of a small number will be very large. So once I take the reciprocal of this, maybe it's somewhere over there. So same x coordinate, but the height has gotten bigger because the reciprocal of a small number is large. All right. And once again, I have a height here of 4, so the reciprocal of 4 will be 1/4. And once again, I just graph that. I just connect the dots, and there's my graph right there. Great. All right, so now I need to focus on this part of the graph, and then I'll be finished the problem. Once again, let's find some random values. Here's a random value right here. This has a height of 1, 2, 3, -4. So this has a height of -4. -4 is considered a large number, so the reciprocal of a large number will be small. So this would be 1 divided by -4, which is about -0.25. All right, here's another good point on my original graph. This has a height of -2. So the reciprocal of -2 would be a -1/2, which is about there. And then I have a point here. This is another good point. It has a y value of -2, and the reciprocal of -2 is -1/2. So somewhere around there. And once again, I just connect the dots, and there is my graph. So the graph highlighted in blue, that represents your reciprocal function. All right, let's move on now. Let's talk about absolute value functions now. Y equals to the absolute value of f of x. An absolute value function will take any y value with a negative value and change it to a positive one. All right, so let's take a look at that. I'm using the same linear function, y equals to x minus 2. Here are some random x values, and here are my corresponding y values, -1, 0, 1, 2, and 3. So this is pretty easy to graph. But now we want to graph its absolute value function. Now once again, if you want to find the corresponding y values, all you have to do is take your x values, plug them in, and you'll get your y values. Or you could use this new rule. An absolute value function will take any y coordinate with a negative value and change it to a positive one. So if I look at my original function here, y equals to x minus 2, you'll notice that this coordinate right here is the only coordinate where I have a negative y value. So for the absolute value function, I just take any y coordinate with a negative value and change it to a positive one. So this -1 will become positive 1. And since all of these values are not negative, you just kind of leave them the same way. So this would be 0, this would be 1, this would be 2, and this would be 3. Okay, and that's it. Absolute value functions are a little bit easier than the reciprocal function. Let's take a look at a few more examples. Before we get on to a few more examples, here are some basic rules again. If a value was already positive, it will stay positive, and we did see that. To graph an absolute value function, take any part of the graph below the x-axis and vertically reflect it above the x-axis. And here's a little special note. Any number outside the absolute value sign will be performed afterwards. Okay, so what does that mean? Let's take a look. I've got two more examples here. In this example right here, my function is inside the absolute value sign, but over here I have this -4, which is outside the absolute value sign. So how will we graph these two functions? Well, for this function, we would first take the absolute value of the parabola, and then we would move the function 4 units down. But in this case, we would shift the graph 4 units down. Here's this -4. We shift it 4 units down first, and then we would apply the absolute value sign. All right, so we got to remember that when we're graphing absolute values. All right, let's take a look at another example here. Given the following graph, draw the absolute value function. All right, so step number 1 is you need to find any values that are below the x-axis. So take any part of the graph below the x-axis and vertically reflect it. So this part right here that I'm kind of highlighting, this part is definitely below the x-axis. So all I have to do is I just need to reflect it across the x-axis. And there we go. There is my reflection. So this is the absolute value. This whole thing is considered the absolute value function. Let's take a look at another example here. All right, I have this polynomial function. So you'll notice that this part of the graph is below the x-axis, and this part of the graph is below the x-axis, and this part of the graph is below the x-axis. So there's three parts that we need to focus on. So once again, take any part of the graph below the x-axis and vertically reflect it. Okay, so there's my first reflection, and next I'm going to reflect this part. So it should look like something like that. There we go. And finally, I'm going to reflect this part as well. And there it is. So there it is. This is what my graph will look like when I take the absolute value function, when I take its absolute value. All right, let's move on. Graph the given function y equals to the absolute value of 2 divided by x minus 3 plus 1. All right, so when we graph something like this, we can break this down into a few steps. So I can graph the function y equals to 1 divided by x, which is the basic reciprocal function from grade 11 math. So let's just graph that. There it is in red. All right, so there's my 1 over x. And then I'm going to try to apply this 2 here. So now I'm going to graph y equals to 2 divided by x. So I'm slowly building up to this function right here by breaking it down one step at a time. And if I have a 2 here, this could be a horizontal expansion by 2 or a vertical expansion by 2. So there's my 2. Let's just say it's a horizontal expansion by a factor of 2. All right. So there it is. I apply that. And then I would take x minus 3. So now I'm shifting the graph 3 units to the right. All right. So a horizontal shift of 3 units to the right. So let's do that. All right, I'm going to shift it over 3 units to the right. All right, and then I'm going to take the absolute value function now. So remember, when we have the absolute value function, we take any part of the graph that's below the x-axis, which is this part right here, and we're simply going to reflect it across the x-axis. So let's do that. And this is what I would have once I take the absolute value. And finally, I have a plus 1, so that means I need to shift the graph 1 unit up. And there it is. The graph has been shifted 1 unit up. So this is my this graph here in blue would represent this function right here, y equals to the absolute value of 2 divided by x minus 3 plus 1. All right, let's take a look at the final example now. Kind of like a final question to summarize the absolute value function as well as the reciprocal function. So given the graph of f of x, graph the following. All right, so this red graph represents f of x, and this graph right here is also f of x. It's the same graph. And now I want to take the absolute value of this red graph. All right, so when we're taking the absolute value, all we're doing is we're taking parts of the graph below the x-axis and we're just reflecting them. So this part is below the x-axis as well, and we're just going to reflect that. All right, so that part's been reflected. Sorry, it's taking a little bit longer than expected. This part's been reflected, and there you go. This is the absolute value function. And you'll see that I don't have any negative y values. All right, now let's move on to this function right here. This is my original function, and let's take the reciprocal now. Step number 1 is we got to find the x-intercepts. So I have an x-intercept there, and I have an x-intercept right there. All right, so once I have my x-intercepts, I draw in my vertical asymptotes. And then all we have to do is we got to find some random points and take the reciprocal value of the y coordinates. And so this is part of my graph. As you can see, my red graph right here has a height of -1. The reciprocal of -1 will be -1. And all these values in between, they're very small, so the reciprocal of small will be very, very big, and that's why my graph is getting bigger down here. Now over here, all we have to do once again is we need to find any value, any y value, and we just take the reciprocal of the y value. And then if we do that, we get something like that. So notice that my red graph has a height of 1 there, so the reciprocal of 1 will be 1. Once again over here, my red graph has a height of 1, and the reciprocal of 1 is 1. Over here, my y values, they're consistent, or they're constant. They have a value of 2 right here, and the reciprocal of 2 is a half. That's why we have this half here. Okay, and once again in this region, all my y values are very small, like a half, a quarter, and the reciprocal of those numbers will be very, very big, and that's why the graph is bigger in this part of the graph. This is why the graph is bigger in this region. All right, for this final part right here, it's interesting. We have a y value of -1, so the reciprocal of -1 will be -1. And so our reciprocal will look like this. And then this part of the graph, it's small, so the reciprocal of small is big. All right, so that concludes the final lesson, and we'll see you again in the next chapter.